Hey everyone. So in the last video, we went into the intro of setting up our TWAP Oracle project, understanding how Foundry works after installation and setting up the modules. And so now we're going to go into, number one, what a TWAP Oracle is going to do with your contracts and how anybody can use this. And then also initiating the factory pattern. So the factory or what the factory pattern really is, what it's doing, and why you would want to use it, and then also doing a small upgrades contract specifically for the beacon. So in our case, we want to create an Oracle beacon because we will be doing the Oracle pattern, and we'll go over that more in a future video, and then tie this video up on setting that up. So the very first thing we want to do is kind of explain what a TWAP Oracle is doing and why you would want to use it. And so as an example, Uniswap uses TWAP, and that's just time-weighted average pricing to understand what the pricing will be for a single pair. So in the case of USDC to wrapped Ethereum, how much USDC I need to give to get X amount of WETH. And so that's really, really good, and it allows other contracts to call that. But what if I just looked at that or made that call and saw what the actual pricing is at the time, but somebody decided to manipulate the price and do a massive buy order or a massive sell order, which would manipulate the actual weights or the weighted adjustment, and whatever my pricing that I was pulling would get manipulated in a way that there could be some type of either malicious activity going on or something along those lines in other protocols. And so it's not necessarily safe to have just a reference to what the current pool is weighted at, because of the possible manipulation. And so the TWAP is basically an average pricing over a time period of what the price has been over X amount of time. So in the case of the last 15 minutes or an hour or a day, we can do an average pricing. And so in our contract, what we want to do is we want to save all of that information. So we could do an average pricing over any amount of time as long as we're pulling that data in. So our TWAP Oracle is going to be a true Oracle where others can use this information. In our case, we'll do one pair where we just watch one pair, and we'll constantly update it through Chainlink automation to gather weeks, months, or years of TWAP data, and so others can use that over a time-weighted area. And so if we decide that our pair should be time-weighted over a 24-hour period, and in that 24-hour period we have numerous calls to see what the price is. That way, when a user says, hey, I want to know what the price is of USDC to WETH, they'll be able to have the most relevant and most exact average pricing that you can get. And so now that we have a high level of what TWAP is, why you would use a TWAP Oracle, let's start building out our upgradable contracts scheme and then go from there. And so to begin with, let's create an upgrades directory. And this upgrades directory will kind of have our logic of what our beacon chain will look like. And in there, we will create a beacon Oracle, or we'll call it an Oracle beacon. And what this will do is, like it's called, it will be a beacon to an implementation contract. So we'll have one base implementation contract that others, when they want to create a new TWAP Oracle, will point to reference. And so every time somebody wants to make a new TWAP Oracle for another pair, it will deploy that new contract, which is just an implementation of our Oracle beacon. So to do an initial setup, we'll do the SPFDX license, do unlicensed for now. We're going to set up a pragma version of 13. And we're going to start importing our upgradable beacon. And that will be from, let me just grab the whole link so I don't waste time typing this out. Great. So now that we have the upgradable beacon, we can also import the ownable. So the ownable contract just allows us to have an admin of the contract in a little easier fashion than us creating the whole logic ourselves. So we'll import the ownable, and we will, as you can see, Copilot will try to create it for us. And almost, but not quite, but we'll take it from here and edit it. So the Oracle beacon is doing, you cannot inherit from the upgradable beacon, so that's out of there. But you can be from ownable. What we should do is we can keep the constructor this, but we should call it a blueprint. So I'm going to do init blueprint. And what this will be is the contract address that we want to point to. And then it's always good to do versioning. So we can do a string and create the versioning to pass in. So in the case of version 0.0.1 for your first, you'll know from querying this that the next version is 0.0.2, and you can reference that in some other fashion if you want. So we don't need this here, but we can create a beacon actually up here as a state variable. So this will be an upgradable beacon, public beacon, and then also a string, which is just the current version. So now we have this, we can save this in state. This is not, the Oracle beacon is not upgradable, so we won't be upgrading this. So whatever you're doing in here, make sure that this is what you want. So in the constructor, we'll create a new upgradable beacon and then pass in that blueprint. So this will create a new beacon contract with that points to the blueprint that we pass in, and then a current version, which is just the version that we pass in. So when we create a new beacon or point to a new blueprint, if we need to make updates, we can just call it a different version. Cool. So now that we have this, we will have an upgrade function, so that's good. We want to, again, we are not calling it new implementation, we'll call it the new blueprint. And we will call data the updated version. And up here, we won't call this, but we will call the beacon.upgrade to. So what version that we're going to upgrade the beacon to. And then again, the current version is going to be updated to the new version, just so we have state updated. So we're going to add a couple others. So the function of implementation we can do is basically allowing us to see what the current implementation is, so what the current contract is pointing to. What this does is when you call this implementation in Etherscan or however you want to look at it, for a get function, this will call the actual implementation contract, so you can see what the current contract looks like, and then also another helper function, which is just get version. And so this will get us the current version of what we have saved in state up here. So that should be it for Oracle Beacon. The next thing that we want to do is we want to start with our TWAP Factory Oracle and start updating on what that should look like and what we should pass in here. So let's start off with just updating some of the different libraries that we'll be using and imported functions. So I'm going to copy and paste the ones that we need. So just to run through here, we have the enumerable sets. This is going to be taken and used in the future. Some of the interfaces for the V2 pairs, the V2 factory that we'll be referencing as well. We are going to be creating the Uniswap V2 factory library. So here's the library contract as well. We're going to be creating our own fixed point number system. We'll talk about that in the future. Because it is upgradable, we'll have our own ownable upgradable, pausable upgradable. We'll be importing some of the automation compatible interfaces as well, just so we can actually have automation in our contracts. And then obviously the interface for the TWAP Oracle that we will create, and then the factory that we'll create. So let's end this video with creating the init function. So any upgradable contract will need an initiate function or initialize function, and what this does is it's basically a pseudo constructor. We won't have a constructor, but we will have an initialize function that needs to be called to initialize the contract. So let's create the function, which is a initialize. This will pass in a factory. It's up to you. I kind of go back and forth with doing underscores for the beginning of parameters. In this case, let's just stick with factory, and the address, which is going to be the address of the keeper registry, and we'll go over what the keeper registry is in a second. But for now, let's just pass that in, and then the address of the owner of the contract, which is going to be the person who deploys from the factory. So we want to know that it's public, which is good, but we are going to initialize, pass in the modifier of initialize. We don't need all of this, and we don't need this. So now that we have the initialize modifier, this will initialize, call the initialize modifier, which is passed in from the initialize function up here. So it's either it's either ownable or pausable, I forget which one, but one of them has a passed in inheritance, which is initialize. So we want to start passing in what we're going to be calling inheriting from. So we're going to be inheriting from the ownable upgradable. And we're going to be also inheriting from pausable upgradable. You need to remember that with any upgradable contract, you need to use the ownable, or for any Open Zeppelin contracts, you will need to use the upgradable versions of those helpers. Most have them, not all of them, but they will not work if you use just the regular ones, because they use constructors and not initializers. So now that we have those, we can come down to our initialize and then add our inherited functions here, because we are both ownable and pausable. We're going to underline or underscore double underscore the ownable init, and then also double underscore the pausable init. So now when we create this and deploy this contract, it will be a true initialized contract, and nothing else will need to be done because we have the ownable init and pausable init. Cool. So now that we have this, let's end this video. We can go more into what the factory will look like in the next video, and then really start diving into what the TWAP Oracle functions will look like, and then finally get into the automation portion.